Today, I will be sharing with you a simple trick to easily balance chemical equations by looking at 5 different problems. By the way, why do we balance chemical equations? The answer is not to score marks in exams, that is one thing, but the main reason is to follow the law of conservation of mass, which states that matter cannot be created or destroyed. Our first problem is hydrogen reacting with oxygen to form water. This is the unbalanced equation that we have. Step 1 is to count atoms on both sides. First of all, make a list of all the elements present in this equation. We have hydrogen, written as H, and oxygen, written as O. So, for both left and right sides, check how many atoms of each element are on both sides. On the left, we have one H2 molecule. That means 2 hydrogen atoms. We also have O2. That means 2 oxygen atoms. On the right, the small 2 after hydrogen means there are 2 hydrogens. The oxygen does not have any small number, so it means it is 1 oxygen, so the right side has 2 hydrogens and 1 oxygen. Now we start balancing. We are only allowed to change the big numbers in front of the atoms or molecules, called coefficients. We are not allowed to touch the small numbers that are the part of the chemical formula. Those tell us the identity of the compound. Now we have unbalanced oxygen. We have 2 oxygens on left and 1 on right side inside H2O. So to fix it, we will put 2 in front of H2O. This way, we now have 2 H2O molecules, and thus we have 2 times 2 or 4 hydrogen atoms and 2 times 1 or 2 oxygen atoms. Let us check hydrogen again. To make them equal, we will put 2 in front of H2 on the left. That means 2 times 2 equals 4 hydrogens. And that's it. Both sides match. This is the balanced equation. Let's move to our second problem. Nitrogen reacts with hydrogen to form ammonia. This is the unbalanced equation that we have. Let's count atoms. On the left, we have N2, which means 2 nitrogens. We also have H2, which means 2 hydrogens. On the right, we have NH3, which means we have 1 nitrogen and 3 hydrogens. First, we will fix the unbalanced nitrogen. On the left, we have 2 nitrogens, but on the right, only 1. So, we will put 2 in front of NH3. That gives 2 nitrogens and 2 times 3 or 6 hydrogens on the right. On the left, we have 2 hydrogen, but on the right, we now have hydrogen 6. To fix this, we will put 3 in front of H2 on the left. That gives 3 times 2 equals 6 hydrogens. This way, both sides have the same number of nitrogen and hydrogen atoms, and this is the balanced equation. Now, let's level up our gear and do our third problem. Methane reacts with oxygen to form carbon dioxide and water. This is the unbalanced equation. Let's first count atoms. On the left, we have 1 carbon, 4 hydrogens, and 2 oxygens. On the right, CO2 has 1 carbon and 2 oxygens. H2O has 2 hydrogens and 1 oxygen. So the right side in total has 1 carbon, 2 hydrogens, and 3 oxygens. Carbon is balanced. Now hydrogen is not balanced. On the left, there are 4 hydrogens, but on the right only 2. To fix this, we will put 2 in front of H2O. Now, the right side has 4 hydrogens, but again, calculate the number of oxygen atoms. It will be 2 from CO, 2, and 2 from H2O. So we have 4 oxygen atoms, and thus oxygen is not balanced. To fix this, we will put 2 in front of O, 2 on the left. Now the left side has 4 oxygens, and this way both sides match. Let's look at a new type of problem where polyatomic ions are involved. The unbalanced equation is calcium sulfate plus sodium nitrate gives calcium nitrate plus sodium sulfate. Step 1 is to count atoms. But here, instead of splitting everything apart, we notice something important. On both sides of the equation, we have the same group SO4 and also the same group NO3. These groups are called polyatomic ions. They stay together like a team, so we can count them as one unit instead of breaking them into sulfur and oxygen or nitrogen and oxygen. This trick makes life easier. On the left, calcium sulfate has one calcium and one sulfate. Sodium nitrate has one sodium and one nitrate. On the right, calcium nitrate has one calcium and two nitrate groups. Sodium sulfate has two sodiums and one sulfate. Now compare both sides. Calcium is already balanced. The sulfate group is also balanced. But sodium and nitrates are not balanced. To fix them, we can put 2 in front of sodium nitrate on the left. That means now there are 2 sodiums and 2 nitrate groups on the left. This way, we have our balanced equation without even thinking of breaking down the polyatomic ions into separate atoms. Finally, let us solve a difficult problem in order to become a pro in balancing chemical equations. The unbalanced equation is carbon plus sulfur dioxide gives carbon disulfide plus carbon monoxide. You know the drill. Let us count atoms on both sides. On the left, we have a carbon with no small number attached to it, so that means 1 carbon atom. We also have sulfur dioxide. That means 1 sulfur and 2 oxygens, so left side totals are 1 carbon, 1 sulfur, and 2 oxygens. On the right, we have carbon disulfide, which is 1 carbon and 2 sulfurs, and carbon monoxide, which is 1 carbon and 1 oxygen. So the right side totals are 2 carbons, 2 sulfurs, and 1 oxygen. Now we start balancing. Remember the big rule. The small numbers or the subscripts that are part of a chemical name are part of the compound and cannot be changed. The only thing we may change are the big numbers written in front, called coefficients. Look at sulfur first because it is easy here. The right side has 2 sulfurs in carbon disulfide, while the left side has only 1 sulfur inside sulfur dioxide. To fix sulfur, we will put 2 in front of sulfur dioxide on the left. So the left side now has 2 sulfurs, and 2 times 2 equals 4 oxygens. Next, let us fix oxygen. After our change, the left side has 4 oxygens, but the right side has only 1 oxygen from carbon monoxide. To match oxygens, we will put 4 in front of carbon monoxide on the right. That means 4 times 1 oxygen equals 4 oxygens on the right. Now, recount carbons and oxygens on the right. Carbon disulfide gives 1 carbon, and carbon monoxide, with coefficient 4, gives 4 carbons. So the right side now has a total of 1 plus 4 equals 5 carbons, 2 sulfurs, and 4 oxygens. The right side has 5 carbons, while the left side currently has only 1 carbon. To fix that, we will put 5 in front of carbon on the left. After this change, we now have 5 carbons on the left side. And that's it. This way, we now have a balanced equation. Also, we only changed coefficients, not subscripts, so the chemical identities stayed correct. If you enjoyed this video, please don't forget to like, share, and subscribe to our channel. Also, you can support my channel by joining our community and becoming a member. So good!